So now we'll be solving question number 15 from phase 1, last chapter, which is forces and the laws of motion. This is from the exercise 1. Okay, let's read it. So a rope of mass 0.5 kg, the mass of the rope is generally the mass used to be, the rope used to be massless, but in this case, mass is given. The thing is, if the rope is massless, throughout the tension is same. But in this case, since rope is having the mass, the throughout the tension, same tension we cannot assume. Okay. Might be same, it might not be same. Now, 0.5 kg is pulling a block of mass 10 kg. So this rope is pulling a mass of 10 kg. Total system's mass will be 10.5 kg. Under the action of force, 31.5 Newton. So this is a block, the mass is 10 kg. And then there is a string, a row, which is 0.5 kg. And there is a force acting on it, which is 31.5 Newton. There is no friction anywhere. Now, if the block is resting on a smooth horizontal surface, so since there is no friction anywhere, now calculate the force of reaction exerted by the block on the rope. The language is important here. We have to calculate the force of reaction exerted by the block on the rope. So here, what is happening? The rope is applying a force onto the system, and the reaction force acting in the opposite directions. If this is F dash, this is also F dash action reaction. The block is moving because this rope is applying a force at this end in the forward direction. The amount of force rope is applying onto the block is same as the amount of force block is applying onto the rope because of third law, action reaction. Okay. Now, in this case, first thing we want to do, we want to calculate the acceleration. Okay. So let's assume this whole system is moving with acceleration A. That's what we are assuming because system will be moving. And to calculate the acceleration, what I'll do, I'll assume this whole system as my system. The block plus rope as my system, I'll assume. If I'm assuming this whole thing as my system, the mass of my system in this case becomes 10.5 kg. Let's make the F variable. The whole system. So mg will be acting downward onto the whole system. Now onto the whole system, when I'm saying mg is acting downward, so here m is for the whole system. Normal action will be acting in upward direction. And there is one force which is acting here. So this is now this rope is a part of the system. So any force which is acting on the rope from the outside is acting on the system. So it is 31.5. Under the influence of the force, whole system is moving with acceleration A. Now it's a whole system which is moving. So along the x-axis, we can balance the force. So along the x-axis, if we see net force is 31.5, that will be equals to m into A. Now m will be total mass of the whole system. Total mass of the whole system is 10.5 times of A. This will cancel out 3 times. So acceleration is coming out 3 meter per second square. So under the influence of this force, 31.5 Newton, the whole system is moving with acceleration 3 meter per second square. But the acceleration, calculation of acceleration was not the question. Our question was how much reaction force this block is applying onto the rope. So what I'll do, in place of calculating this F dash, I'll calculate this F dash because ultimately they are action-reaction pairs. So in place of calculating the reaction force on the rope by the block, I'll calculate the force on the block by the rope, which is this. And this force is acting here. I'll make one more FBD. And this time, my system is going to be only the block. Only this block. If this block is my system, then this force is not acting on the system. This is outside. If this block is my system, then on the boundaries, only this force is the external force. So if I make this block is my system, then downward force is mg, but this time m is 10 because my system is only this. So 10g, normal action upward direction, and there is this F dash force. This F dash force is applied by the thread. onto the block. Now the thing is, whole system is moving with the acceleration 3 meter per second square. Since whole system is moving, then rope is also moving with same acceleration. Block is also moving with same acceleration. So acceleration is same, that is 3 meter per second square. I'll balance along the x-axis. So along the x-axis, the force acting is F dash, which we need to calculate. Mass is 10 for the block multiplied with acceleration, which is 3. That comes out to be 30 Newton. So the force applied by the rope onto the block is 30 Newton. In the question, they are asking about the force by the block on the rope, which is also 30, but in the backward direction it will be, because action-reaction pair. Okay. So sometime in place of calculating force by the block on the rope, calculate the reverse and use the laws of motion. This is third law of motion, basically. Okay. Thank you.